In a small workshop in rural Pakistan, a massive V8 diesel engine awaits another chance to be brought back to life. Covered in years of dirt, burnt oil, and signs of extreme wear, it seems to be at the end of its life. But here, where experience is valued more than modern machines, nothing is discarded so easily. Lunge das grandes cidades e das oficinas equipadas com scanners eletrónicos e ferramentas computadorizadas, a mecânica tradicional paquistanesa continua funcionando de maneira simples, artesanal e impressionantemente efficient. O que mantam esses motores vivos neo a tecnologia de ponta, mas conhecimento acumulado ao longo de décadas. This Nissan V8 has already faced tough roads, constant overload, and limited maintenance. In many places, an engine in these conditions would be replaced immediately. In Pakistan, it represents work, survival, and opportunity. The first contact with the engine reveals the scale of the challenge. The block is covered in thick layers of oil mixed with dust. Dried-out hoses, makeshift bolts, and clear signs of overheating show that it has operated far beyond its limits for quite some time. Each mark on this engine tells a story. More than that, it reveals an entire culture based on the reuse and recovery of equipment that can still function. The disassembly begins slowly. The mechanics remove each piece with extreme care. There is no rush. Each component removed is carefully separated while the internal condition of the engine begins to be analyzed. The cylinder head, heavy and covered in combustion residue, requires strength and experience to remove. The environment is simple, but there is absolute concentration at each stage of the process. The diagnosis here does not depend on computers. The mechanic rotates the crankshaft manually, observes small clearances, listens for almost imperceptible noises, and interprets signals that only years of practice can identify. It's an engineering feat built on observation, touch, and technical memory. As the engine is completely disassembled, the damage becomes clearly visible. Scratched cylinders, accumulated carbon, parts worn from constant friction, and signs of high temperature show how much this V8 has worked throughout its life. But for these mechanics, this doesn't mean the end. The parts will be cleaned, adjusted, and manually reconditioned. The block will be prepared again, salvageable components will be given a new lease on life, and everything will be reassembled almost exactly as it was done decades ago. In workshops like this, each simple tool carries years of adaptation. Hammers, worn wrenches, and old machines continue to function daily because necessity demands constant creativity. In Pakistan, rebuilding an engine of this size costs only a fraction of the price of a new one. That's why workshops like this remain essential for trucks, machines, and vehicles that keep entire cities running. What's most impressive is that, even without sophisticated equipment, many of these engines continue to operate for years after rebuilding. When the process is complete and the V8 finally starts running again, it's not just a machine that comes back to life. It's the direct result of human skill, persistence, and grassroots mechanics who survive amidst hardship. This type of work shows a reality little known outside of Pakistan, where practical experience and artisanal engineering continue to power giant engines every day. If you enjoy following complete rebuilds, heavy mechanics, and real processes done from start to finish, follow the channel and continue exploring content where scrap metal is transformed into power again. Over the next few hours, the engine will be completely disassembled. Each part will undergo cleaning, inspection, and detailed analysis. Only the truly compromised components will be replaced. In Pakistan, simply replacing everything is not a viable option. The logic here is to recover, adapt, and reuse as much as possible. A large part of the parts used in this reconstruction do not come from large industrial manufacturers. They are produced in small local workshops scattered throughout the cities and industrial neighborhoods, places where traditional mechanics still resist the advance of modern automation. This Nissan V8 engine relies entirely on this invisible network of specialists. Each workshop masters a specific stage of the rebuild. While one is responsible for crankshaft grinding, another performs cylinder honing. Elsewhere in the city, technicians work on valve seating or the artisanal fabrication of metal gaskets. Everything functions like a huge, decentralized production chain, sustained not by digital contracts or big brands, but by a reputation built over decades of work. It's a silent engineering feat, practically unknown outside of Pakistan, but it keeps trucks, heavy machinery, and old vehicles running daily even in extreme conditions. And the further the process advances, the clearer it becomes that this reconstruction goes far beyond fixing an engine. It represents an entire industry based on manual skill, adaptation, and survival. The next step is a thorough cleaning of the parts. In modern workshops, this process would be done with ultrasonic machines and automated equipment. Here, everything is done manually, following simple methods that have been working for decades. Regular diesel is used as a solvent to dissolve burnt oil, carbon, and residue accumulated over the years. Metal brushes remove the heavier crusts while mechanics patiently work on every detail of the engine. The internal lubrication channels receive special attention. Each oil passage is manually cleared to ensure that the flow returns to normal when the engine is restarted. Any internal blockage could destroy all the rebuilding work in just a few minutes of operation. The surfaces of the block, cylinder head, and covers are carefully scraped. The goal is not to make everything look pretty, but to preserve as much as possible of what can still be reused. It's a slow, repetitive, and extremely important job. In a diesel engine of this size, small metallic residues or carbon deposits can compromise lubrication, generate overheating, and cause a new mechanical failure. Even without sophisticated equipment, mechanics know exactly where to look for wear, cracks, and deformations. Experience replaces technology in almost every step. After cleaning, one of the most important stages of the entire rebuild begins: the technical inspection of the internal parts. Each component is carefully analyzed. The mechanic observes signs of friction, overheating, and small deformations that could compromise the engine's operation after assembly. Even working in a simple workshop, precision remains essential. Using basic measuring instruments, technicians check internal clearances and analyze wear on the crankshaft journals. The ovality of the parts is also carefully examined, as any irregularity can generate vibration, loss of oil pressure, and premature wear. The entire process depends much more on practical experience than on sophisticated electronic equipment. The trained eye of the mechanic often identifies problems that would go unnoticed by someone without years of practice. If the crankshaft shows excessive wear, it can be manually polished to recover part of its original surface. In more severe cases, the part is sent to a specialized local grinding shop. These traditional grinding shops are part of a mechanical network that still survives strongly in Pakistan. The machines used are often decades old, but continue to operate daily thanks to constant maintenance and the technical expertise of the operators. It is common to find old equipment functioning with surprising precision in the hands of professionals who learned the trade through practice, long before the arrival of digital technologies. In this environment, manual skill and experience remain the most valuable tools in the workshop. Over the next few hours, each component returns to its place. The crankshaft is carefully repositioned. The pistons descend back into the cylinder liners, now with new rings, ensuring a proper seal. The torque applied to the bolts doesn't come from a calibrated tool, it comes from experience, from the sensitivity in hands that have tightened thousands of similar assemblies. This process requires calculation, experience. Every hundredth of a millimeter directly influences the oil pressure and the future durability of the engine. It's not just about fitting parts together. It's about restoring internal tolerances originally designed by Japanese engineers, now interpreted on the simple workbench of a traditional Pakistani workshop. The camshaft is one of the most critical components in the entire assembly. In a V8 diesel engine, it is responsible for precisely controlling the opening and closing times of the intake and exhaust valves. Any uneven wear on this shaft directly compromises combustion efficiency, fuel consumption, and even engine durability. Pistons are one of the most important parts of any diesel engine. Inside this Nissan V8, they work under extreme conditions, enduring constant explosions that transform combustion energy into mechanical force capable of moving tons daily. When the pistons are finally removed from the block, signs of wear appear immediately. The top part, known as the piston crown, is covered by a thick layer of carbon buildup. This dark accumulation is the result of years of incomplete combustion, something very common in engines that operate continuously under heavy load, limited maintenance, and inconsistent fuel quality. Each mark on this surface reveals the intensity of the work faced by this engine over time. In addition to carbon buildup, mechanics check for lateral scoring, heat-induced deformations, and possible excessive clearances between the piston and the cylinder wall. In diesel engines, any small alteration in internal tolerances can compromise compression, oil consumption, and performance. Approved pistons then proceed to cleaning and preparation. Those that show severe wear are replaced with new parts produced locally or refurbished by specialized workshops in the region. After that, the new piston rings arrive. These rings have a fundamental function: to seal the compression inside the cylinder, control the lubricating oil, and transfer some of the piston's heat to the engine block. The correct size choice depends directly on the final diameter obtained after cylinder honing. Before final assembly, the rings are carefully positioned with the gaps misaligned. This simple detail is essential to prevent compression leaks and ensure efficient engine operation after starting. The pistons are installed using a fairly simple, but extremely important, compression tool. It temporarily compresses the rings to allow the assembly to slide smoothly into the cylinder. At this point, any mistake can cause immediate damage. The inner walls of the block have just undergone the honing process, creating tiny microscopic grooves responsible for retaining the lubricating oil. If the piston enters misaligned or with excessive force, this entire surface can be damaged. Therefore, even in a simple workshop in Pakistan, assembly requires absolute concentration, steady hands, and a great deal of practical experience. It is in this balance between manual technique and mechanical precision that this old V8 slowly begins to come to life again. When they slide back into the cylinders, clean and prepared, the pistons symbolize the rebirth of the engine. They are what will receive the pressure from combustion, transfer force to the connecting rods, and return, upon turning the crankshaft, the continuous movement that defines the essence of a V8. Each reinstalled piston represents not just a replaced part, but also recovered compression and efficiency. Even after years of extreme use, this process guarantees a second life. The cylinder head is, without exaggeration, the most sensitive part of the entire assembly. It is where the final control of combustion takes place, where air, fuel, and compression meet above all others. In a diesel engine, the cylinder head needs to withstand high pressure and constant thermal cycles without losing its seal or alignment. With the engine block completely reassembled, the final stage of the rebuild arrives. The last parts begin to be installed while the engine slowly recovers its original shape. Hoses, supports, fuel system, manifolds, and auxiliary components are put back in place after hours of intense manual work. Now everything approaches the most anticipated moment in the workshop, the first start. But before the engine truly starts running again, there is an essential procedure. The lubrication system needs to be prepared manually. The mechanics apply oil directly to strategic points to ensure immediate protection during the first internal rotations. Diesel fuel flows through the fuel lines again for the first time since the beginning of the disassembly. Each connection is carefully inspected to avoid leaks or pressure failures. At this moment, the engine is not yet igniting. It rotates slowly only during startup, allowing the oil to circulate through the bearings, internal galleries, and moving components. This process is fundamental to avoid dry wear in the first rotations after the rebuild. The silence in the workshop changes completely. Everyone attentively observes every detail. Any unusual metallic noise, any irregular vibration, or minor lubrication failure could indicate an internal problem. After hours of careful disassembly, manual cleaning, precise measurements, and patient reassembly, the moment finally arrives when all the work will be put to the test. And then it happens. The old Nissan V8 diesel engine is running again. The initial smoke, the heavy sound of compression, and the characteristic engine vibration reveal that this worn-out structure, which seemed condemned to abandonment, has managed to return to life once more. It's impossible not to admire the skill level of these mechanics. Even working with simple tools, far from modern workshops and computerized equipment, they manage to recover giant engines using only experience, manual technique, and practical knowledge accumulated over the years. This is the reality of survival engineering in Pakistan. If you followed this reconstruction this far, you already understand the value of this type of work. So take the opportunity to subscribe to the channel, comment on which part caught your attention the most, and share the video with anyone who also enjoys hardcore mechanics and heavy engineering. Because the most impressive thing isn't just seeing an engine start running again. It's realizing that, in places where almost nothing can be wasted, knowledge and skill remain the most powerful tools of all.